Find the branch currents using a method of your choice. So the possible answers are already given. We are going to analyze first the given figure. So here we have our loop 1, our loop 2, our loop 3, our loop 4. And we can also see that this figure has super mesh, and this will be our super mesh. What we are going to solve are IA, IB, IC, ID, and IE. First is to apply the KVL at the super mesh. So 40I1 minus 40 multiplied by 30 plus 10 multiplied by I1 minus I3 plus 35 multiplied by I2 minus I3 plus 150 equals to 0. Just copy 40I1 and multiply 40 by 30, which will become negative 1,200 plus multiply 10 by I1 and I3, which will become 10 I1 minus 10 I3 plus multiply 35 by I2 minus I3, which will become 35 I2 minus 35 I3 plus 150 equals to 0. So as we can see here, we have two i's and only one I2 and two I3 and two constants. So first, we're going to solve for I1. 40 plus 10, which will become 50 I1. Since 35 I2 is the only one, just copy 35 I2. Solve for I3, which are negative 10 minus 35, which will become negative 45 I3. And solve for the constants. The constants are negative 1,200 plus 150, which will become 1,050. And this will be our first equation. Next is solve for mesh 4. So apply mesh analysis in loop 4. So 10 multiplied by I3 minus I1 plus 15 ID plus 35 multiplied by I3 minus I2 equals to 0. So the same process, 10 is multiplied by I3 and I1, which will become 10 I3 minus 10 I1. Since 5 ID is the only one, just copy 15 ID. And then since 35 will be multiplied by I3 minus I2, so it will become 35 I3 minus 35 I2 equals to 0. The same process, however, there is only one I1, so just copy negative 10 I1 and negative 20 I2 because the 15 ID minus 35 I2, that's why it became negative 20 I2 plus we have here 2 I3, 10 plus 35, which will become 35 I3 equals to 0. So this will be our second equation. After a mesh equation is formed, a dependent source equation is needed. This equation is generally called a constraint equation. Our third equation is just constraint the equation. So I1 minus I2 equals to negative 3 IA. So this will be our third equation. IA is equal to I1 minus 30. This will be our fourth equation. So, next step is substitute equation 4 to equation 3. So, I1 minus I2 is equal to negative 3 multiplied by I1, minus 30. So just copy I1 minus I2 is equal to negative 3I1 because we multiplied negative 3 to I1. So it became negative 3I1. And then multiply negative 3 to negative 30. That's why it became positive 90. So transpose negative 3I1 to the left side. That's why it became positive 3I1. Copy I1 minus I2. So 3I1 plus I2 minus 3I1 plus I1 minus I2 equals to 90. So it became 4I1 because here the value of I1 is equal to 1. So 4I1 minus I2 equals to 90. So this will be our fifth equation. Next step is use the Cramer's rule to evaluate I1, I2, I3 from equations 1, 2, and 5. So let us go back to equations 1, 2, and 5 and check if there are values for I1, I2, and I3. So equation number 1 has 50I1, 35I2, and negative 45I3. So it is complete. Equation number 2 has negative 10I1, negative 20I2, and positive 45I3. So it is already also complete. In equation 5, we have 4I1 and we have I2. Since I have as what I have said earlier, in I1, I1 is equal to 1. And also in I2, it is also equal to 1. So the value for I2 here during the solving is 1. However, there is no I3. So if there is no I3, we can conduct it as 0. So our I1 is 4, our I2 is negative 1, our I3 is 0 equals to 90. To get I1, I2, I3, follow this pattern. I use the scientific calculator, click mode or setup, use the equation under number 5, so click number 5. Click number 2 and substitute all values in I1, I2, and I3. So put all values in I1, I2, I3 from equation 1. So I1 in equation 1 is 50, I2 is 35, I3 is negative 45, and the constant is 1050. In the equation 2, our I1 is negative 10, our I2 is negative 20, our I3 is positive 45, and our constant is 0. In our equation 5, we have I1 which is 4, our I2 is equal to 1, so our I2 will become negative 1, and our I3 is 0, and our constant is 90. So the matrix is already complete, so let's check. Our x is equal to 24, but we let it as I1. So our I1 is 24a. Next. Our y is equal to 6, but we let it as I2, which is 6a. And our z is equal to 8. We let it as I3, which is equal to 8a. So, the answer for I1 is 24a. In I2 is 6a. In I3 is 8a. So, since the I1, I2, and I3 are already given, we can already calculate IA up to IE. So, IA is equal to 30 because as you can observe here, 30A is already given. So 30 minus I1, since our I1 is 24, so 30 minus 24 is equal to 6A. IB is equal to I3 minus I1. Our I3 is 8 and our I1 is 24. So 8 minus 24 is equal to negative 16A. IC is equal to I3 minus I2. Our I3 is 8. Our I2 is 6. So 8 minus 6 is 2A. Our ID is equal to I2. The value for our I2 is 6A. So just put 6A. And our IE is equal to I3. The value of our I3 is 8A. Just copy 8A. So the answer for our IA is 6A. So let us check in the possible answers given if it is correct. So IA is equal to 6A. It is the same. Next is, in the IB, our answer is negative 16A. Let's check if it is the same. IB is equal to negative 16A. In IC, the answer is 2A. In the ID, answers is 6A, IE 8A. So the answers are 6A, negative 16A, 2A, 6A, 8A. So let's check if our answers are the same. So 6A, negative 16A, 2A, 6A, and 8A. So our answers are the same with the possible answers given. Thank you for watching.